everyone, it's Fernanda again. Welcome back to GED On. On today's video, we're going to be covering part 1 of chapter 2, decimals and fractions. Now, chapter 2 is pretty long, so we went ahead and split it into 2 videos. Therefore, it's very important that you watch part 2 after finishing today's lessons. As you already know, GED On was created to follow along with the Kaplan book. This video you can use as a resource as you start working towards your GED. So please remember that you are more than welcome to pause and replay the video at any time. Now, let's go ahead and get started with our first lesson. All right, everyone, like always, we will be continuing to utilize our Kaplan GED Test Prep Plus 2020 book for this and all GED On videos. You can find links below in the description box to buy this book either online or at your local store. Now, let's go ahead and get started on our first lesson. On today's video, we will be covering Unit 2, Mathematical Reasoning, Chapter 2, Decimal Fractions, Part 1. Now, this is a very long chapter and it will be split into 2 videos, so please make sure to watch Part 2. We will be starting today's lesson with Lesson 1, found on page 238. Okay, Lesson 1, Decimal Basics. Alrighty, let's keep it chugging along. So we are going to be moving on to comparing and ordering. Comparing decimals is similar to comparing whole numbers. But let's see this in an example so that we can see it visually. So our example 2 states, Matt ran the 400-meter race in 45.8 seconds. Alonzo ran the same race in 45.66 seconds. Which runner had the faster time? Let's go ahead and break this down into steps as well. Step 1. Line up the decimal points. Add a 0 at the end of 45.8 so that both numbers have the same number of digits after the decimal. So you can see that I've already done that in color blue. So this gives us 2 digits after the decimal point for both 45.80 and 45.66. Step 2. Compare the decimal parts of the number as though they were whole numbers. So this step is going to take a little bit of pretending, you could say. In this case, 80 is greater than 66. So 45.8 is greater than 45.66. Another way to look at it is to round the decimals so that they have the same number of digits after the decimal. Now, in this case, it would be 45.66 rounded to 45.7. Now, the reason that it would be 0.7 is because the digit after the first 6 is greater than 5. Therefore, 0.66 would automatically get rounded to 0.7. Now, this is smaller than 45.8. Therefore, that gives us a final answer that Alonzo had the fastest time. Okay, final example of this lesson. Example 3. Arrange the numbers 0.85, 1.8, 0.8, and 0.819 in order from greatest to least. Like before, we'll go ahead and break this down in steps. So to make it a little bit easier, our first step is going to be to write the numbers in a column where we will be lining up the decimal points. Then we can add 0 so that the numbers have the same number of decimal places. So as you can see here, we have already done that for you. Now, as a next step, we are going to compare the digits working from left to right. Given that only 1.8 has a whole number part, we automatically know that it's the greatest. So you can see that all of the remainder of the numbers start with 0 point, but only 1.8 has an actual whole number, which in this case is the 1. The remaining numbers each have 8 in the tenths column. Look at the hundreds column. 0.85 would technically be the next greatest number. Then it would be followed by 0.819. Now we know this because the third number, 0.8, technically has a 0 right after it, so it doesn't actually give it more value. When we compare 0.85 and 0.819, we know that if we were to round 0.819 so that it only had 2 decimal places after the decimal, we would have 0.82. Now 0.82 is still smaller than 0.85. Therefore, our final answer by arranging the numbers from greatest to least is 1.8, 0.85, 0.819, and finally 0.8. Now that we have finished our first lesson, we are going to move on to practice 1, which you can find on page 239. At this time, you can go ahead and pause the video to read and complete practice questions section A, 1 through 6, which you can also see on the screen. After you have tried your best to work through them on your own, go ahead and click play so that we can review them together. Alrighty, let's go ahead and work through some practice questions together. All of these practice questions are asking us to round to a certain area on the number line. So let's start with question 1. Round 3.75 to the 10th place. Now, to make it a little bit easier for us, I have provided the number line below. Given this number line, we know that the 10th place is the spot immediately to the right of the decimal. That means that we are going to have a final answer that will look like number, decimal, number. Now, as a step 1, we are going to look at the number to the right of that is currently in the 10th place. In this case, the number to the right of 7 is 5. This indicates to us that we are going to have to round up. This will give us a final answer of 3.8. Question 2. We are going to round to the ones place. This is a little bit different than the practices we have done before, as we have always rounded numbers that are to the right of the decimal. But in this case, the ones section is actually to the left of the decimal, but our same rules apply. So we are going to look to the right of the number that is currently in the ones place. In this example, that number is 9 as it is to the right of 5. Because 9 is 5 or greater, that means that we are going to round up, giving us a final answer of 6. Question 3. A calculator display reads 0.4285714. Round to the nearest hundredth. Again, from our number line, we can see that the hundredths place is 2 places after the decimal, or to the right of the decimal, which means that our final answer is going to look like number, decimal, number, number. The digit that is currently in the hundredths place is actually 2. The number to the right of that is 8. This indicates to us that we need to round up. Therefore, this gives us a final answer of 0.43. All right, halfway there. Question 4. Round 0.66667 to the nearest thousandth. The thousand spot is 3 places to the right of the decimal, which means that our final answer is going to read as number, decimal, number, number, number. The digit that is currently in the thousands place is 6. If we look to the right of that, we have another 6. This indicates to us that we are actually going to have to round up. Therefore, our final answer is going to be 0.667. Okay, question 5. Round 8.125 to the nearest tenth. We can see the tenth is the spot immediately after the decimal line. Therefore, our final answer is going to read as number, decimal, number. If we look at the right, we see that the digit 2 is right next to it. But because 2 is less than 5, that means that we are not going to round up. We're going to leave it the same. So this gives us a final answer of 8.1. Final question. A calculator display reads 2.7142857. Round to the nearest thousandth. Okay, so again, the thousands place is 3 places to the right of the decimal. Therefore, our final answer is going to read as number, decimal, number, number, number. Now, the digit that is currently occupying the thousands place is 4. If we look to the right, we see that the next number is 2. Similar to before, 2 is less than 5. Therefore, we cannot round up and we're actually going to leave it the same. So our final answer rounded to the nearest thousands is going to be 2.714. Now that we have worked through the first couple of problems together, go ahead and pause the video and complete practice questions section B through D on your own. Remember that you can find the answers at the back of the book. Once you're ready to continue, go ahead and click play. Okay, cruising right along, we are going to move on to lesson 2, decimal operations. Now that we have discussed the basics of decimals, let's talk about how to manage them in mathematical operations. Now, adding decimals is very similar to adding whole numbers. The easiest way to do this as a first step is to write the numbers in a column by lining up the decimal points, like we have done in the past. Let's look at how to do this with an example. Example 1, add 0.37 plus 3.5 plus 2.638. So like before, we're going to work through this problem in a series of steps. Now that we know that step 1 is to write the numbers in a column, make sure to line up the decimal points. If you'd like, you can also add placeholder zeros so that the decimals have the same number of decimal places. But that's really up to you. So at this point, we can go ahead and begin to add. We're going to start on the right and add each column. So as you can see, we have rewritten the numbers to the right, so therefore we can work through them together. And we made sure to line up the decimal points. So let's go ahead and start at the right column. This gives us 008, so we're going to add those together. So if we add them together, we have 8. We're going to move on to the next column, 7 plus 0 plus 3. This actually gives us 10. So we are going to head and put a 0 here, but we are going to carry over that 1 from the 10 to the next column. So now, technically, we have 4 numbers in this column to add. We have 1, 3, 5, and sits. This gives us a total of 15. So we're going to do the same. We're going to place the 5 here, and then we're actually going to carry over another 1. Next column. At this point, we are going to add 1, 0, 3, 2. This gives us 6. For our last column, we only have one number. So that gives us 1. Now, at this point, we can see that our final answer is actually going to be 16508. Now, please remember that you're going to want to place the decimal in the answer directly below the decimal points in the problem. So you can see that decimal here. This gives us a final answer of 16.508. Now that we have learned to add, we are actually going to move on to subtraction, also known as finding the difference. To find the difference between decimals, we need to write the numbers in a column with the greater number on top. Let's go ahead and look at an example of this. Example 1. Find the difference between 14.512 and 8.7. We will solve this problem using very similar steps as before. Let's start with our basic step, which we've already mentioned, but it doesn't hurt to cover it again. We are going to write the numbers in a column. We are going to line up the decimal points and add any placeholder zeros so that the numbers have the same number of decimal places. Now remember that this is optional, but if that helps you, please go ahead and do so. So here we can see that we have written our numbers in a column, with 14.512 being on top, given that it's the greater number. At this point, we can go ahead and just subtract. Like before, we are going to start at the very end column, or the column that is most to the right. So we have 2 minus 0, which gives us 2. Then next column, we have 1 minus 0, which gives us 1. Now, you can see here that we're kind of in a tricky situation because we have 5 minus 7. Now, we can subtract that, but really what we're going to want to do is get a number from the right of that. So we're going to borrow. So what that means is that we are going to change both 5 and 14. So now, because we have borrowed, this means that we have borrowed 1 from 14. So we've taken 1 away. Now that has turned into 13. The 1 that we have taken away, we are actually adding to 5, making it 15. Now, we have 15 minus 7, which gives us 8. For our final column, we are actually subtracting 8 from 13. This gives us 5. Now, as you can see from the instructions, we did regroup and borrow as needed. Now, we're going to place the decimal point in the answer directly in line with the decimal points in the problem. This gives us a final answer of 5.812. Now that we have reviewed Lesson 2, we are going ahead and move on to Practice 2.1, which you can find on page 241. Like before, please pause this video and work through the problems Section A, 1 and 2, and also problems 4, and 5. Once you have done your best to do them on your own, go ahead and click play so that we can review them together. Okay, let's go ahead and work through these problems together. We are going to start with problem 1. 4.025 plus 3.971. Like before, we're going to go ahead and start at the column to the most right. This is going to be 5 plus 1. That gives us, of course, 6. Moving on, 2 plus 7, 9. 0 plus 9, 9 again. And finally, 4 plus 3, which gives us 7. Therefore, our final answer is 7.996. Question 2. Now this one looks a little bit different because 6.5 does not have the same number of decimal points as 4.008. So as I've mentioned, you are more than welcome to add in placeholder zeros if you'd like. So now we can go ahead and start adding. Starting at the right, we have 0 plus 8, which is 8. 0 and 0, 0. 5 plus 0 gives us 5. And finally, 6 plus 4 gives us 10. So we have a final answer of 10.508. All right, question 4. This is actually a subtraction problem. So we have 8.04 minus 2.19. So again, we can see that in the very first column, we have the number 4, which is smaller than 9. So we are actually going to be borrowing. If you want to go ahead and look a little bit further, we also see that in the next column, 0 is less than 1, which means we're also going to have to borrow for 0. This is going to impact the entire top section of this problem. So let's go ahead and work through that together. So we are going to borrow, borrow, borrow. What this is going to give us is 3 new numbers on top. So because we borrowed a 1, this turns 4 into 14, 0 into 9, because we've already borrowed 1, and 8 to 7. So what we actually have now is going to cause us to do 14 minus 9, which in this case is 5, or all cases, I guess. Then we have 9 minus 1, 8, and finally 7 minus 2, which is 5, giving us a final answer of 5.85. Next question, 8.5 minus 1.074. So again, we're going to add in our placeholder zeros and do the borrowing game once again. So we're going to borrow, borrow, borrow until this changes our numbers to 10 and 9. Now we have 10 minus 4, which gives us 6, 9 minus 7, which gives us 2, and then we have 4, because we did take away from that 5, so 4 just gets brought down. And finally, 8 minus 1, giving us 7, for a final answer of 7.426. Great job, everyone! Now that we have completed those practice questions, go ahead and pause the video and complete practice questions section A through B. Go ahead and click play when you're ready to continue. Okay, y'all, time for the last topic of this lesson, multiplication and division. So the rules that we use to multiply whole numbers can also be used to multiply decimals, which is actually pretty easy. However, it is important to note that you do not have to line up the decimal points in order to multiply. You will need to wait until you are finished multiplying before you place the decimal point in the final answer. The number of decimal places in the answer equals the total number of decimal places in the numbers that you are multiplying. So it's kind of a lot to take in, but it will make more sense as we work through an example. So our current example tells us or asks us to find the product of 2.6 and 0.45. So remember that the word product is also an indicator of a multiplication problem. So first step, we're going to set up the problem as though we were multiplying the whole numbers 26 and 45, even though their decimal points are in different places. So here you see we have already lined them up. And now we're going to work through them together. Now, even though we can already see the first step of our multiplication problem here, we're still going to work through it one by one. So as you know, in a multiplication problem, when it's lined up in a column, we are going to start at the bottom right corner. In this case, that number is 5. So let's go ahead and start. We first have 5 times 6, which is 30. So we would actually put a 0 here, and we are going to then carry over a 3. That gives us 5 times 2 plus 3, giving us 13. Or in this case, 130. That's how it currently looks. Now, we're going to do the same for the number 4. So we are first going to multiply 4 times 6, which is 24. Okay, now, even though we know that's 24, we're actually going to add in a 0 first. So that's pretty common of multiplication problems. Now, we will place the 4 to the left of it, and we are going to carry over a 2. Now, we finally have 4 times 2 plus 2. So 4 times 2 is 8 plus 2 gives us 10. Therefore, the second half of this multiplication problem is 1040. Now, let's go ahead and bring everything together. If we add up those two numbers, we have 0 plus 0, which of course equals 0. 3 plus 4, which gives us 7. 1 plus 0 gives us 1. And 1 on its own is 1. So now we have 1170. But this, of course, is not the final answer. So we're going to count the total number of decimal places in the numbers that were multiplied. So in the original problem, we have 2.6. That gives us 1 decimal point. In 0.45, that gives us 2. So we add those together. We're going to say it's 3 decimal spots. So starting from the 0, we're going to move over 1, 2, 3. That gives us the ability to put a decimal point between 1 and 1. Therefore, our final answer is going to be 1.170. Now, let's take a peek at solving a division problem together. For this example, we are going to divide 14.4 by 6. So before we start solving the problem, let's go ahead and set everything up. So we're going to set up the problem by placing the dividend within the brackets and the divisor outside of the brackets. Okay, now the divisor or the number that you are dividing by is a whole number. In this case, it's 6. Therefore, we're going to place the decimal point in the answer directly above the decimal point in the dividend, or the number that you are dividing. So the dividend is 14.4. So let's go ahead and start moving through this problem. 6 divides into 14 2 times at most, given that 6 times 2 is 12. So we are then going to put 12 under 14. Now, unlike an addition problem, in division we're actually going to subtract. So we have 14 minus 12. This leaves us with a remainder of 2. Now, you can see that there is a 4 there, and that's because we brought down the 4 of the dividend so that it's next to 2. So now we ask ourselves, how many times can 6 be divided into 24? In this case, it actually divides into it equally by 4. So we do 6 times 4 equals 24, which we're going to subtract from the 24 above it. This will finally give us a remainder of 0. Now that we're here, we're going to place the decimal in accordance to the number of decimal places within the problem. Because 6 is a whole number, there's no decimals. So we have to do it based off the decimal places of 14.4. Now, if we look at it, there's only one decimal place. So that means that the decimal can get moved just one time in the final answer, giving us a very final answer of 2.4. Next example. In this case, we have divide 4.9 by 0.35. So we're going to follow the same steps. Let's go ahead and put it in the division bracket. We have 0.35 dividing into 4.9. Now, you probably already know that we're going to have to move the decimal point in order for this to work. So what we are going to do is to move the decimal places so that both of the numbers are whole numbers. So that means that for each number, we are going to move the decimal place 2 times. Now we do 2 times because 0.35 requires it to move twice in order to be a whole number. If we were to move it 3 times, we would have to add a 0. And even though that doesn't change the actual number value, we have to be based off of this particular number. So now that gives us a new division bracket of 35 getting divided into 490. And you can see where the actual decimal point is to the right of 0. So let's work through this together. So we know that 35 cannot get divided into 4, but it can get divided into 49 one time. So 35 times 1 gives us, of course, 35. We're going to subtract 35 from 49. This will give us 14. Now, we're still going to bring down that 0, even though it doesn't technically have a value, but we're going to bring it down. So 35 gets divided into 140 4 times, equally, which is nice. So now we are going to do 35 times 4, giving us 140. So we're going to subtract those until we have a remainder of 0. Now, the final step is to add in the decimal point. So we can go ahead and put the decimal point exactly where it is within the 490. So essentially we're just going to be moving up this decimal point right after 4, giving us a final answer of 14. All right, so moving right along, we're going to go ahead and do practice 2.2, which you can find on page 243. Like before, go ahead and pause the video so that you can work through problems 1, 4, 7, and 10 of section A. Once you have worked those to your best ability, go ahead and click play so that we can work through them together. Okay, so we're going to go ahead and work through these problems starting at problem 1. We have 5.3 times 0.5. So let's start at the bottom right-hand corner with 5. So 5 times 3 is 15. That means that we're going to carry over a 1. 5 times 5 is 25, plus 1 gives us 26. Now obviously we're not quite done yet, so we're going to move on to the second section. Now remember that we always add a 0 to that second line to begin. Looking at the bottom left corner, we have a 0 in the problem. So we're going to do 0 times 3, which gives us 0. 0 times 5, which also gives us 0. So that second line is composed of nothing but zeros. At this point, we are going to subtract all those zeros from 26.5. That gives us a final answer of 2.65. Now, the reason that it's 2.65 is because we only had to move the decimal twice. And that is because in 5.3, there's only one decimal place, and in 0.5, there is also just one decimal place. Together, that gives us 2. Therefore, we would move the decimal place twice to give us 2.65. Let's look at a division problem. We have 3.12 divided by 6. So in this case, we know that 6 does not divide into 3, but it can get divided into 31. So it will divide into 31 5 times, given that 6 times 5 gives you 30. Subtracting 30 from 31 gives us a remainder of 1. But then we're going to bring down that 2, which really gives us 12. We know that 12 can get divided by 6 2 times, giving us 12 again. So we are going to subtract those, which gives us a remainder of 0. Now, because 6 is a whole number, but 3.12 is not, we're going to move our decimal in accordance to 3.12, which gives us 2 decimal places. That means that the actual decimal point will be put after the 0, giving us a final answer of 0.52. Next problem. We have 6.25 times 1.4. So let's quickly work through it. Starting at the bottom right corner, we have 4 times 5, which gives us 20. So we're going to put a 0 and then carry over our 2. 4 times 8 gives us, 4 times 2 gives us 8, plus 2 gives us 10. So we're going to carry over another 1. 6 times 4 is 24, plus 1, of course, is 25. Now, we have 1 times 5 is 5, 1 times 2 is 2, and 6 times 1 is 6. So now we're going to subtract 625 from 2500. This gives us a final answer of 8.75. Now, you may be wondering why there is a decimal within 8 and 7. And that is because in 6.25 we have 2 decimal places, and in 1.4 we actually have 1. So that really gives us 3. You'll also notice that after the 5 on the second line, I did not place a 0, but it's still there. Therefore, there is a 0 next to the 5 in the final answer. So if we put in what we'll call a placeholder 0, that actually gives us 3 decimal places, hence the final answer of 8.75. Last question. We are going to divide 30 by 1.25. Now, we know that we can technically divide 1.25 into 30. However, to give it or treat it as a whole number, just like 30, we're actually going to move the decimal point so that we really have 30 being divided by 12.5. So 12.5 can get divided into 30 2 times. This gives us 25. So we're going to subtract that like always, which leaves us with 5. And then also we're going to bring down a 0. You might not see the 0 there, but it is in existence. So 12.5 gets divided into 50 4 times, giving us 50, which is nice. So that leaves us with a remainder of 0. Now, we are going to go ahead and move the decimal point so that it's after 4. Because 30 is already a whole number, we can pretend that the decimal point is actually after that 0. However, for 1.25, we did have to move it. So therefore, our final decimal point is actually going to be right after the 4. But in reality, the actual answer is just 24. But remember that 24 is the same thing as saying 24.0. All right, it's that time again. Go ahead and pause the video and complete practice questions, section A through B. Go ahead and click play when you're ready to continue. Lesson 3, Fraction Basics. All right, so now we are moving on to fractions. A fraction utilizes 2 numbers to represent part of an entire whole. The bottom number is called the denominator, which showcases how many equal parts are in the whole group or item. The top number is called the numerator, and it showcases how many parts you're actually working with. So let's go ahead and look at an example of this. Our example states, there are 4 equal parts in this particular rectangle. 3 parts are shaded. Therefore, 3/4 of the rectangle is shaded. So here we see our actual rectangle. We can see that this rectangle was divided into 4 sections. 3 of those sections are blue. So 3 of the 4 sections are shaded, hence our fraction of 3/4. Okay, so now a little bit more about fractions. A proper fraction represents a quantity less than 1. In a proper fraction, the numerator is less than the denominator. However, an improper fraction is equal to or greater than 1. That means that the numerator will actually be greater than the denominator. Let's look at some examples of this. There are 6 equal parts in the figure, and 6 are shaded. Therefore, 6/6 is shaded, giving us a total of 1. So we can see that the rectangle does in fact have 6 parts, and they're all shaded. Now remember that if you have a numerator and a denominator that are the same number, the same whole number, they are always going to equal to 1. So whether it be 2 over 2, 3 over 3, 8 over 8, those are still equal to 1 because the entire thing is completed. Let's look at a second example. In this grouping, each figure is divided into 2 equal parts. So we have 2 circles that have 2 equal parts. A total of 3 parts are shaded. Therefore, 3 over 2 parts are shaded, or 3 halves. So unlike the example above, we're counting these 2 circles as an entire whole. So if we were to count this as an entire whole, we actually have 4 parts, but only 3 of those are shaded. So therefore, we have 3 over 2. So even though there are 4 parts, they're technically 2 parts of 1 circle. So you have 2 circles. So again, you have 3 parts of these 2 circles that are shaded, giving us 3 halves. Now, because we're talking about math, there are, of course, a bajillion ways to look at one thing through different lenses. So, we also have something called a mixed number, which is another way to show an amount greater than 1. A mixed number consists of a whole number and a proper fraction. A proper fraction being that the numerator is less than the denominator. So let's look at our 2 circles again. So we've already determined that the fraction for this is 3 over 2. But if we want to change it to a mixed number, it's going to look different. So really, what we have here is 1 and 1/2. So I know that's a little confusing, but it's because we're looking at it a little bit different now. So the 1, or the whole number, comes from the fact that we have 1 whole shaded circle, where the 1/2 comes from the fact that we have 1 circle that's only half shaded. But again, we're counting this as an entirety, those 2 circles. So what we really have is 1 full circle and half a full circle, giving us a mixed number of 1 and 1/2. Okay, so now let's look at an example. We're going to change 16 over 5 to a mixed number. Therefore, we're going to have to do a little bit of dividing. So we're going to take our 5, which is going to go outside the division brackets, and our 16, which goes inside the brackets. So we are literally dividing 16 by 5. Now we know that 5 goes into 16 3 times, which gives us 15. If we subtract those, that will give us a remainder of 1. Now we could keep going, but because we're changing this to a mixed number, we of course are going to have a remainder. So, because 16 was not easily divisible by 5, that's why we have a remainder of 1. As you know, if it would have been divisible equally, you would have a remainder of 0 like we've seen in the past. Now, in order to change this to a mixed number, the answer becomes the whole number and the remainder becomes the numerator of the proper fraction. The denominator, however, is going to stay the same as the original fraction. So what this is going to give us is a final answer of 3 and 1/5. So again, the answer to the division problem, which is 3, is going to be the whole number. The remainder is the numerator, and the denominator will be the same denominator of the original fraction. From our previous lessons, we know that division and multiplication have a special relationship, just like addition and subtraction. So before we did division, in order to change the improper fraction into a mixed number, if we work backwards, we're actually going to use multiplication. So let's do that in this example. We are going to change 7 2/3 to an improper fraction. So remember that an improper fraction has a greater numerator than it does a denominator. So let's break this down. We are going to take 7, or the whole number, and multiply it by 3. This gives us 21. Now remember, like before, the denominator always stays the same, and the whole number is the answer to the original problem. So therefore, 7 times 3 equals 21. Now, we are going to take 21 and add 2 to it. The 2, if this was a division problem, would have been the remainder. Therefore, we add it back together because remember, we're working backwards. So we have 21 plus 2, giving us 23. Now, we are going to take 7 2/3, which is the original problem, and turn it into the improper fraction of it, which is 23/3. Now you can see here that the denominator did not change, and that's where that 3 came from, where 23 was the product and the addition answer of the entire process. Let's keep talking about fractions. In order to perform operations with fractions, it is necessary to be able to write equal fractions in higher or lower terms. Terms are the numerator and the denominator. A fraction is reduced to lowest terms when the two terms do not have any common factor except 1. So to raise a fraction, we're going to multiply both terms by the same number. So in this case, we can go ahead and multiply both 3 and 4 by 3. So you can see that the fraction is actually written a little bit longer here. So we have 3 times 3 and 4 times 3, which gives us 9 by 12. So if we were to look at 9 by 12 and we want to reduce that, we know that both 9 and 12 are divisible equally by 3. It's a multiple of both 9 and 12. So if we were to work backwards, we would get the original fraction of 3/4. To reduce a fraction, we are going to divide both terms by the same number. So in this case, both 10 and 15 are divisible by 5 equally. So we have 10 divided by 5 and 15 divided by 5, which gives us 2/3. If we were to work backwards and multiply both 2 and 3 by 5, it would take us back to our original fraction of 10/15. Before moving on to our next lesson, let's go ahead and take what we learned and put it into practice. We will be conducting practice 3, found on page 245. All right, everyone, go ahead and take this time to pause the video and complete questions 1 through 3 of practice 3. Once you're ready to continue, go ahead and click play so that we can work through them together. Okay, welcome back. Let's go ahead and work through these together. We're going to start with the very top graphic. So here we have a rectangle that is split into 5 parts. Now, remember that in a fraction, the entire whole is equal to the denominator. We can see from this figure that 3 of these 5 sections are shaded. Therefore, to turn this into a proper fraction, which as a reminder is when the numerator is smaller than the denominator, this would give us a fraction or a final answer of 3/5. This means that 3/5 of this particular figure are shaded. So let's look at the next one. We have a graphic that has 4 different parts. 2 of those parts are shaded. So we know that 4 is going to be the denominator and 2 is going to be the numerator. But of course, we're not quite done yet, as we can reduce 2/4 into 1/2. And that is because both of these numbers are equally divisible by 2. 2 divided by 2, of course, is 1, and 4 divided by 2 is 2. Now remember that going forward, and particularly important in the actual GED test, is that you're always going to want to reduce your fractions to your best ability, as those will actually be the final answer. So while technically 2/4 is not incorrect, because it can get further reduced, we know that 1/2 is actually the final answer. So last figure, we have a rectangle that has been split into 3 parts horizontally. So 3 will be our denominator and 2 will be our numerator, giving us a final answer of 2/3, or 2/3. Now that we have completed practice A 1 through 3, go ahead and complete practice questions B through F by pausing the video. When you're ready to continue, go ahead and click play. Great job, everyone. We made it through the first half of Unit 2, Mathematical Reasoning, Chapter 2, Decimals and Fractions. Now up next, we have Part 2. Stay tuned.